still awake after lunch?
No.
Ooh, is there more coffee out there? Oh, all right, so it's my job to keep you awake.
Sing.
Cell phones. If they ring, I answer them, or I have Grant answer them. Grant is even a better choice. All right, the doors are closing. You're stuck in here with me, so you have about 30 seconds to decide if you indeed want to hear about proactive data growth management and compression, or if this is not the session you meant to be in. All right, nobody got up and left. Excellent. There's more people coming in still. Even better. All right, the doors are closing. Come on in. Don't be shy. Don't be shy. So good afternoon, everyone. I am Jess Schultz-Borland. I'm a SQL Server consultant at Brent Ozar PLF. I am from Oshkosh, Wisconsin. Drove down here yesterday, so thank you for having me. Thank you, Redgate, for putting on this great day of training and networking, and so I'm going to talk to a few people. So today, we're going to be talking about proactive data growth management, but first I have a little bit of a story. See, I used to be 6'3". I could even dunk a basketball. But the problem was that I took up a lot of space in the bed. I ate a lot. I already eat a lot, I ate more. I drank a lot of coffee. I drank more. I know you find that hard to believe as I reach for the cup of coffee I have sitting up here. I was using a lot of resources. That wasn't necessary, so I decided to compress down to this compact 4'12". It seemed to work a lot better, except I'm still drinking a lot of coffee. Now, what does that have to do with anything? Well, it kind of relates to you and your data. The world is full of data right now. So let's talk about it, because we're all here because we deal with data and databases, whether we're programming for it, storing it, managing it, etc. How much data is in the world?
Lots.
Yes, a lot. That's good. Yes, this is interactive. I like questions. I like people talking. So feel free. Feel free. First, one single website, Facebook, which almost everyone is on Facebook. Over 100 petabytes of data on that one website alone. EMC estimated that in 2011, so last year, over 1.8 zettabytes of data were created. That's a lot of data, and that's in one single year. That's not counting what was created in 2010, what was created in 2009, not counting the insurance agency that's keeping data going back 100 years. Think about all the data that you alone have, all the pictures that you store of the dogs and the pets and the family parties. Think about the videos that you have of skydiving or things like that. Think about all the things you keep, not only for yourself, but others. I mean, I'm a runner. Everyone that follows my Twitter feed probably knows that. I track all my run data, and I post that up on their website. We have bank account information, which is stored on people's websites. We upload our documents to Google Drive, and we also have a copy on our hard drives, and we probably have a copy on a USB drive somewhere. Data is everywhere. So now, in a more specific sense, let's talk about your data, specifically your company data. How many databases do you have overall? Let's play a game. Let's figure out who has the most, shall we? Give me some numbers. 1,300. 4,400?
45.
45?
4,500.
Oh, okay. 45 is like 45. I might have that many on my VMs. 4,500. Other people, hundreds, thousands of databases, correct? You're running with a lot of data. How much storage space are they taking up? Does anybody even know how much storage total their databases are using? Grant.
The system I used to have was
terabytes in production and 5 terabytes in dev.
There you go. 1 terabyte production, 5 terabytes in dev. Let's talk about also how many copies you have of each database. Chances are you don't have just a production database. That's bad, because we don't want to let the developers run wild in production. As a developer, I didn't want to be the one running wild in production. So all of these things add up to more and more and more data existing on your systems and in the world overall. And we are tasked with being the stewards of this data. We have to take care of it. We have to make sure that it can be accessed quickly. We have to make sure it can be backed up. We have to make sure it is restored. That's a big responsibility, and the more you get, the harder it gets to wrangle. It's like herding cats. So let's keep talking about why there is so much data, because these are important things to understand. Where it's all coming from helps us understand what we can do with it. We keep creating data. As I mentioned, you keep taking photos. People keep creating new businesses. People keep being customers of businesses. There are a million reasons that more data is created every day. Think about new products created. The information about those has to be stored, whether it's a user's manual or photos of it or videos on how to use it. There's several reasons for that. Lots of us have data retention policies. You know, how often can you say, my database is getting too big, I'm just going to go in and delete some of it. Exactly. And that's not even counting what we have, that's just our business reasons. Let's talk about things like SOX and other compliance. You have to keep data for X amount of time. You can't ditch it in some cases. Again, going back to multiple versions of the same database. You have testing, you have QA, you have production, you have reporting, you may be mirroring, you may be doing log shipping. And I've been on both sides of the fence as both a database developer and a database administrator. As a developer, sure, sometimes I want more permissions in production, but I don't want to be the one deploying changes in production, because when I break something, guess whose shoulder is being stared over? Mine. As a DBA, I don't want people making changes in production, because when that breaks, guess whose shoulder they're staring over? Mine. We've had lots of sessions today around why there should be separate environments, how to manage those, how to control all of the code between them. The fact of life is that they're necessary, but it quickly adds up. 1 terabyte in production, 5 terabytes in development. You also need to have multiple versions of your database backup, because how many of us get to have one full backup each day and some transaction log backups, and then when you have this backup that you took on Monday, and when you get done with Tuesday's backup, you just get to get rid of Monday's. Nobody's really raising their hands. Although Bob does have a great story I'm going to ask him to tell later once we talk about this a little bit more. So you have to keep multiple copies of your database backups for retention reasons. All of this means you have incrementally more and more and more data. You have to manage it somehow. You have to herd the cats. So there's a couple reasons we can, or a couple ways we can handle this. Let's talk about some supposedly easy ones. Perhaps we store less data, or perhaps we just add more storage. Please raise your hand if you can get away with just deleting old or unnecessary data. Grant can, fantastic, thank you. How about those of you that can say, well, my SAN is running out of space, and since the development environment is taking up 500 gigs, I'm just going to get rid of it. We'd like to get rid of some of the data in it, perhaps, but we can't just torch it. We can't just let go of it. How about those of you that have just decided, how many people have ever decided that they don't really need a month's worth of backups. They can probably exist on a week's. Okay, we have had a person, and how did that go?
So far, so good.
So far, so good. Excellent.
They do end up at magical tape lamps sometimes.
Okay, so they
They're
end
not
up in
going
tape.
completely away, but they're
But
not
yeah.
like
So they may not be on your SAN, they may not be on a network drive, but they're on tape, they're somewhere. It's still storage, you're still paying for the physical cost of it, whether that's on a server or storage in a tape room somewhere. So let's talk about adding more storage, because how many of us have heard we're running out of space, we just need to buy more storage. We need to upgrade the SAN. Yes. Doing that isn't always the best option either, because disk is cheap now, it wasn't always, but it's not free, and it's not infinite. Your disk has, you can only buy X amount, and it costs money. And it's not just the actual cost of the disk itself. If that was the only thing we had to worry about, it wouldn't be too bad. But we have to talk about the equipment in general. So you have disk, and the more you get, the more expensive it is. You need more drives for RAID, you need more RAID controllers, you need more cooling. Then you have the utilities themselves. Whether you're adding into your data center that you host, I mean, that's going to take up racks. The more servers you have, the more data center you're going to need. You're eventually going to need a bigger room. This is going to cost money. Or if you have some sort of hosting solution, then you have to think, how much am I paying rack space? What are they going to charge me to add on another 200 terabytes of space? And then there's a big one, the people cost. The more servers you add, the more storage you add, you're eventually going to need to add more people to manage it. Sure, one extremely frazzled system administrator could probably handle all 500 servers, but what are the chances that you ever want to go and ask him or her for anything? And especially as we increase complexity, a couple of rack servers with some direct attached storage is a far cry from what you need when you have a SAN, which has all of the moving parts. You know, the more expensive your storage gets, you're going to have to start paying people more to go through the training or to hire someone that has experience with it. Once you get into things like tiered SANs, you have to have someone that understands how all of that works and can troubleshoot it. Chances are you can't have just one. You probably need to have two because these people need to sleep. Or not. So the costs of storage are more than just how much will a new set of drives or how much will a new SSD cost me. It's much more inclusive than that. So, what else could we do? We can talk compression. Yes, like taking me down from 6'3" to 5 feet. We can do it in a couple of different ways. We can choose to either compress the data itself as it's on your server, or we can compress the backups. So that's what I'm going to talk about now. We'll start by talking about data compression. This is a native feature starting in SQL Server 2008. And there are two flavors of it, row compression and page compression. Show of hands, who's using either of these right now? Okay, we have a few people. Excellent. How does it work? This is probably the nerdiest part of my presentation. I need to ask why, I need to know how things work. And I figure if you guys are going to be using it someday down the road, and if I'm going to talk you into it, you should probably know too. Row compression. It works by compressing down the amount of space that's used to store the data itself. So things like integers, which normally take up 4 bytes of data, it will store it in as few bytes as possible. If you have character data, say you have a char 25 field, but you're really only storing 8 bytes in this row or 4 in that one, it will only use that. Null and empty values, it doesn't even bother to store those. So it really works on the data itself. Let's look at an example here. Say I have this table with sales order ID, sales order detail ID, order quantity, unit price, and tracking number. Integers, small ints, money, and a char field. Normal storage in bytes. Integer 4, small int 2, money would be 8, and my char 25 is 25. But let's go down here and look at how many bytes are actually being used by these values. 1, 4, 10. So with non-row compressed data, SQL Server would normally use 43 bytes for that. But if we're using compression, this row would only take up 17. Imagine how many more records you can get on an 8K data page when you are using 1/3 of the space that you were before. So what's a great use case for using row compression? Probably an instance where you have a system that maybe came from a vendor or was developed in the past, and they use just whatever data type fit at the moment. Everything's an integer. Everything's a char 255. Everyone has seen that. We've all seen it. That's a really great example. When you have a lot of variable width data, row compression is a really good solution. What if you need more? There's page compression. Page compression takes on these extra fancy terms: prefix and dictionary compression. I like to think of it as sort of maps to the data, almost like a secret decoder ring that you would use to figure out what values are stored on the server. Let's take a look at an example. Let's talk about prefix first. The prefix is what comes at the beginning of the word. So let's take me and my sister, for example. Jess and Jen. Yes, my parents actually named us Jess and Jen. There are different variations of both of these names: Jess, Jessie, Jessica, Jen, Jenny, Jennifer. So to store all of these, SQL Server needs to take up X amount of space. But like a secret decoder ring again, there are repeating values here. So every time Jess is stored, it uses JES. Every time Jessica is stored, it uses JES. Interesting. What if SQL Server could just substitute a value for that and put it in place at the beginning of every string where that would be? That is prefix compression. This again allows it to take up less space on each page. Think of other things that begin with roughly the same numbers. Telephone numbers, zip codes, part numbers. There's a lot of different patterns within your data where if you have things that start at the beginning that are very similar, page compression could be very useful for. It also allows you to use dictionary, did I say header? Hold on. Prefix and dictionary compression. You know what? I bet I was putting this in and I thought I need to add a header to my table, but I typed in header. Sometimes you shouldn't let me near PowerPoint. Okay, dictionary compression. Dictionary works on more than just the beginning. It works on the entire set of data. Let's look at a few of the values that we have here. Strings with commonly repeated sections in them. The values BC, the values DL, the character ZZZ. What will happen here is SQL Server will look for common repeating patterns throughout the data on a page, and it will take and it will substitute a character for those repeated values and just store that. Bonus, if these are in different fields, say it will look throughout all of them. So it's not going to have one list for address and another list for first name and another list for last name. SQL Server is smart enough, it actually is, to be able to look at the different parts of your page and store similar values for all of them. Again, think of how much space you can save if you have a lot of common, repeatable data. So that's a really good use case for page compression. Things where similar values may be stored frequently. How many of us are running maybe order systems where you have prices stored? You know, you can only have, does everything have a different price, or are you running, you know, 100 items are $9.99 each, another 100 are $12.99 each? Start thinking about potential use cases for this. Patterns of repeating data. So that's page compression in SQL Server. But how much can it really do, you ask? Quite a bit. I looked in books online, and Microsoft didn't want to give away any averages or formulas, so I went ahead and I did a little bit of work myself. I took some of the tables from AdventureWorks, and I actually used Atom Mechanics' Big Adventure to help out with this. Looking at two tables, Big Product and Big Transaction History. Big Product with 4.6 megs of data. When I added in or enabled row compression, it took it down by 52%, down to 2.2 meg. And page took it down to 1.7 for a 63% savings. That's just on one table. And a transaction history table, which has a slightly different variations because it records different things, with row compression, 37% savings, and page compression, 59% savings. This is across 1.1 gig. What does that start to look like at 10 gigs? What does that start to look like at 100 gigs? What does that start to look like at a terabyte? The savings are significant. And that's just in one database. What if you have 500? What if you have 4,500? If anyone wants to get out their calculator and start doing some math, feel free. So you can see how using data compression in SQL Server can yield very solid visual results. But there are some costs to it. You knew that was coming. Not everything in life is free. So the one big downside for me as a database administrator is that this is per object in the database. So if I have 100 tables, I need to either go into the GUI and right-click and enable it, or write a script that loops through all of the tables and enables it. Did I hear PowerShell? So that's kind of a downside. There are ways to manage it. People do have scripts out, but then you have to do things like decide, okay, which tables get row compression and which tables get page compression? Or do I just enable one or the other for everything? How do I handle when new objects get added in? Do I enforce that on the developer side? Do I enforce that on the production side? These are decisions that have to be made. They can be made, but you do have to think about them and talk about them. All compression will come with higher CPU usage. That's native SQL Server compression, that's any third-party backup tool. In order to do the compression, your system needs to be able to use CPU. So if you have heavy CPU usage systems, if you have CPU bound, compression is probably not where you want to go. I'd start with trying to get the CPU usage down or upgrading your systems. And a really big monetary killer. Data compression is only available in enterprise. So say you're running a standard edition and you want to start using data compression, how much is it going to cost you to upgrade for that one feature? A lot. It's not an easy, or it's not a cheap upgrade to make for a feature like this. As useful as it could be and as much as it could save you in hardware costs, it does come at a price. So what's another option that we have? We have, ta-da, Redgate SQL Storage Compress. So this is a really, really neat tool that I've used in a couple of different jobs. How does it work? You guys are going to want to know how it works. I know I always do. So it starts by you taking a backup of a database. Production, development, however you want to start. And then you put it through the Redgate tool, SQL Compress. And it uses a hyperback driver to compress the database online when you restore it to another server. So this is at the operating system level. When you look at your data file directory, which we'll do shortly, I do have live demos because those are always the best. You won't see an MDF, you'll actually see a special object there, and you'll see the compressed size. But when you go into SQL Server Management Studio, you will see the database. It looks exactly the same. If you right-click and go to Properties, it shows the normal uncompressed size. It looks kind of magical. It's not, it's just taking place at the operating system level, and that, again, has the CPU overhead. It saves a lot of disk space. The average compression ratio is 73%. Average. So people have achieved higher. That's, again, a significant savings. We're talking, a 100 gig database down to 25 gigs. We're talking a terabyte database down to 300 gigs. Significant savings overall. And for me, the real kicker here can be that you don't have to decide if you want to use row or page compression. You don't have to decide which objects to apply that to. It applies this for the whole database. Poof, all in one. So sometimes, when you want a little bit of easier management, this could be an answer. And here's just one example of what I was able to achieve with my AdventureWorks database. Started out at 2.574 gig, saved 57%, 1,096. All I needed to do was take a backup of my AdventureWorks database and do a restore in the SQL Compress tool. Let's go ahead and take a look at that demo. All right.
Well, while you're setting up for the demo, I'm going to ask the awkward question that, since you don't work for Redgate, you can't answer probably. And that is, I have now completely put my trust in a third-party tool with all my data. If something happens and their compression's bad and I backed up a compressed database and I can't restore it, what do they do for me? I'm putting a lot of faith in a company halfway around the world, to be blunt.
That's a great question. And is Phil here? No? Grant or Steve, would you like to
So it doesn't affect the backup process at ever. You get a normal backup to use.
Yes.
Lightspeed or SQL backup or anything has nothing to do with the compression we did.
So it backs it up as a normal database, not as a compressed database?
Correct.
I could restore it to a different server without...
Absolutely. This
Okay.
has nothing to do with backup. This is
Correct.
live data.
SQL Compress has nothing to do with the actual backups. It just takes you, so you already have a native backup file, a .bak, and it just takes that file. It doesn't change that backup file at all. It simply compresses the database.
Oh, I guess I'm sorry, I guess I'm not clear on my question. I understand that, so I have now a compressed database that I'm updating.
Mm-hmm.
I'm going to back that up.
Yes.
Are you telling me that that's backed up in a normal backup format?
Correct.
It's uncompressed?
Correct.
Yeah,
You can,
never mind, paranoia off.
okay. No, I like paranoid DBAs. It's a good question to ask. These are things you want to check. But yes, if you were to do a backup of it, it would produce a normal backup file. If you were using something like SQL Backup Pro, you'd have the SQL or the Redgate backup files there. But that's a choice you can make.
And because it's the operating system, you can use any tool that you want to do your backups, any of that stuff.
Good question. Because the compression takes place at the OS level, can you use whatever tool you want to do the backups? Yes. You are not tied to SQL Server native backups. You are not tied to SQL Backup Pro. You could use another tool. I had another question.
So when you use a combination of page and row compression, and you back up the same database using compression as well, do you double the amount of space you save, or how does it work?
You guys are asking excellent questions, as Grant Ritchie would say. I'll be doing a separate session about backup compression here shortly. But to make a long story short, if you're already doing row and or page compression in a database, and you apply backup compression, you're not going to see an additional 50% savings. You're not. The data, SQL Server is already smushing it down as much as it can. There will be a small amount because, backups take care of things like what's in the log file, but it won't be as significant as either one separately will be. Okay. Now, the bad thing is that you guys aren't going to see me back here, so I'm going to try to make this better here and move that a little bit. So here is my SQL Server instance, and I have an AdventureWorks database. And Zoomit doesn't like to work on digital machines. Well, if Zoomit was running, that would have helped a lot. Okay, so I have AdventureWorks, and I'm going to go ahead and just open up SQL Storage Compress. When you do this install, it's a two-part install. There's a hyperback file, and then the GUI. There is also a command line, but for the purposes of this demonstration, I'll use the GUI. I'm a bad presenter. I don't have Zoomit installed on this VM. I know, I hear gasps of horror. Let's click back here. There we go. Okay, so I have in SQL Storage Compress, you can see that it lists for this instance the databases that I have, the original size, and then it gives me this wonderful button up here to be able to restore backup to compressed database. Sounds easy enough, right? Let's take a look. I click on that button, and I get to go through a wizard. This is fantastic. I like wizards. It makes it easy. I pick my SQL Server instance to connect to, so this is the server I'm restoring to. I select my backup file. Here I have an AdventureWorks uncompressed backup. I have to try to navigate the multiple windows of the VM. I pick a database name, AdventureWorks SSC. I'm going to call it compressed so it really stands out. You can add in additional features, things that I'm not even going to talk about today, like encrypt it. You can encrypt this database online. You can run a DBCC checkDB right in, so that, because as we know, we want to be doing regular backups, but we also want to be doing regular restores, because your SQL Server backups are only as good as their ability to restore them, and we want to be doing DBCC checkDB to make sure that our data is not corrupted. So with that, it generates a script for us, and you can save this script and then go ahead and check it into source control or run it. In this case, I'm going to go ahead and start the process. Let's take a look at something really important here while this is happening. Now, granted, this is not the world's most powerful virtual machine. I didn't give it a ton of resources. We have one processor and 2 gig of RAM. However, you'll notice that the CPU is really high right now, and there is nothing else going on this VM. So it is something to be aware of, that any amount of compression is going to use more CPU. So this takes a little bit of time. Again, like I mentioned, when you go into SQL Server, you're not going to see a difference. As a matter of fact, if we go into Windows Explorer and pull up the data file, let me just navigate through that. We're going to go into the data directory. And what do I see here? I have the AdventureWorks data, which is a standard MDF, and here's AdventureWorks compressed. And you'll notice that it shows to the OS as a hyperback archive file. It does not show as a SQL Server data file. All of this is taking place at the OS level. Great, it's finished. That was pretty quick. 2.5 gig, again, down to just over a gig. Let's go back to Task Manager. Boom, CPU has dropped significantly. So while the restore is taking place and while the database is being compressed, there is that additional resource hit. What you'll notice then, we go into SQL Server Management Studio. I refresh my list of databases, and here I see another one, AdventureWorks Compressed. And we've got that right up there. You'll notice it doesn't look any different. There's no different icon. It doesn't say anything like when you're restoring a database, how it says it's restoring. Nope, it's just there. And if we right-click and go Properties, it shows the original 2.6 meg. So this is transparent to SQL Server. It's as simple as running a restore, and with the script you can even schedule that out as a SQL Server agent job. So SQL Server Storage Compress is a really great tool to ease the handling of SQL Server compression. Question?
Can you detach and reattach?
Can you detach the database and reattach it? Yes. Again, scripting that out. Question?
How does that work with data file growth? Things like that.
How does it work with data file growth?
You come in here, it's seeing 2.6 gigs. Your data file is almost full. It's time for your periodic growth.
It will auto grow. If you have auto grow settings, it will continue to auto grow. Auto grow can be very helpful. The amount that it chooses to grow, again, that's built into the SQL storage compress and the compression.
Okay.
That may
But
be.
if you're manually growing, auto grow is good to be on in emergency.
Yes.
Not good to actually let it be used.
It's not preferable that it has to be used, yes. But what do you mean? Like when you go to manually grow it, will you see anything different?
It's 2.6 gigs. Okay, I need to add more space.
Okay.
I'm going to manually grow to
The
bypass the whole auto grow.
That would be a great question for a Redgate product specialist. There was another question?
I have a database that is basically storing images of documents.
Okay,
So that is raw data.
yes.
Raw data. Will these two help me to compress that too, or it work only for regular data type?
So we have a database with a lot of blobs, the big blobs. It will still compress. It will not compress as much. That it's not something like integer data or character data where there is a lot of extra space on the data pages. That's handled differently. Again, Redgate product specialist could probably answer better what like percentage of compression you normally see with that.
But it might maybe not be worthy to enable it if it is not too significant, right?
Are you asking like at what threshold does it help? That's a business decision. In some companies, a 10% data savings could be enough. It could be enough for you to say, I want to enable it. In some other companies, they may want to see 30% or 50%. That's a business decision. Another question?
Your question is, initially your goal was to save the data, just to storage, right? So you have one copy of database, now you have another copy on top of it.
Correct, which is, again, an excellent question because the next point that we'll talk about is what are good use cases for SQL storage compress. Generally, and I've heard this repeated in a couple of sessions, this isn't something where you want to go ahead. You may not want to be compressing your production databases. You probably want those to be standard MDF and LDF files with regular .bak. But a really good use case is to take that production database that you have, take the backup that you're taking nightly, weekly, etc., and then you can restore it to a testing environment, a development environment, a QA environment. There, you can throw far more onto one server. You don't need to have as much storage per server. So that's a really good use case for using SQL Storage Compress. But yes, you will still, this works where you are going to have to take at least one backup of the database and have it compressed, yes. I'm being blinded, I'm sorry. There's a question in the back.
Yeah, so is there any information about like overhead that this will cause for queries? So I know there's the CPU overhead whenever you're compressing either within SQL Server native or this tool. But is there any guidelines of what it'll do to your SQL queries?
So what will the compression do to your SQL queries? Again, a little bit of CPU usage, exact metrics, talk to the Redgate team. They're going to have better answers around that. Grant.
In general, there's always exceptions. It will speed them up.
Okay, in general, it speeds up your queries. Even better. You're going through less data.
Right.
You know, think about like even with SQL Server row and page compression, you just don't have as much to page down. Alan.
I know that page and row compression in SQL Server Enterprise Edition, you get a benefit because it stores the compressed pages in the buffer cache, so you get more data in the buffer cache.
Yes.
Does this do that as well or no?
That is a question I don't know the answer
Greg's shaking
to.
his head, so I'm thinking that means no.
Alan wanted to know if, whereas with SQL Server native data compression, if you use row compression on disk, it will also put those pages in memory in the buffer pool compressed. Alan asked if SQL storage compress will also do that. I don't have an answer for that, but Grant says no.
Yeah, it's implemented as a Windows filter driver.
Yes.
And given that, SQL is always going to see it as uncompressed data. SQL will never see the compressed data. So it'll be uncompressed in the buffers.
Excellent. Okay.
Really
Yes.
quick, the engine works on a service, right?
The hyperback service, yes.
If that service for XYZ reason came down, is the database still accessible?
If the hyperback service crashes or is turned off by a sysadmin that goes in and says we don't need this, are the databases still accessible? No, the hyperback service needs to be running for the databases to be running. So yes.
Because one time the trial came down, the service went down, and my test databases, even though I enabled the license again and bring the service back up, the database never came back up. Is that something that really needs to be considered as a risk of using the tool?
Yes, it is something that you have to take into consideration. Again, talk to Redgate about how you can mitigate that risk. Yes, another question.
Since this is at an OS level, can you compress a 2005 database, or is this still just at 2005?
This works with SQL Server 2005 and above. So it does have that benefit over SQL Server native compression. And again, it does all editions of SQL Server as well. You don't need to have SQL Server Enterprise to use Redgate's SQL Storage Compress. Great question, thank you. SQL 2000, I don't believe so. Grant, Steve, do you know for sure?
It should work with 2000.
It should work with 2000?
I think you could compress your text files. It works at the extension level. Filter.
Grant says it'll work with 7. Who's got it? Who has a database in 7 that they'd like to try this out on? All right.
Give me a lesson,
Are there still SQL Server 7 licenses floating around? The sad thing is someone is going to say yes. All right, any other questions around the demo for SQL Storage Compress? But overall, it's fairly simple to use. You take a backup, you do the restore in this tool, you have a much smaller database on disk to be able to run. It saves space in your organization. So the other option that you have, in addition to just compressing your actual data, you have backups. Backups are one of the DBA's